State in order the sequence of transformations that have occurred to y equals 1 divided by x squared to give the equation below. So when we're trying to determine the transformations that have occurred, the first thing we need to do is reintroduce the dashes onto the x and y variables in our image equation. The next thing we do is we try and make this equation here resemble y equals 1 divided by x squared, the basic equation, as much as possible. And to do that, we can start by adding 4 to both sides of this equation. So our equation is now y dash plus 4 is equal to 2 divided by x dash plus 5 all squared. In our most basic equation, which is y equals 1 divided by x squared, there's only a 1 on the top line. So what we can do is we can multiply both sides of this equation by a half, and that will give us y dash plus 4 divided by 2 is equal to 1 divided by x dash plus 5 all squared. So at this point we now have a term involving y equaling 1 divided by a term involving x all squared. So that means that our equation now resembles the basic equation. So everything that's out here we can equate with y, and everything that's inside the square on the denominator we can equate with x. So that gives us two equations. The first is that y is equal to y dash plus 4 divided by 2, and the other is that x is equal to x dash plus 5. Next we need to solve for the dash terms. So for the equation involving y, we can multiply both sides by 2, and that gives us 2y is equal to y dash plus 4, and now subtracting 4 from both sides will give us y dash by itself, and that will be y dash is equal to 2y minus 4. For our equation involving x, all we need to do is subtract 5 from both sides of the equation and we will get x dash by itself. So we find that x dash is equal to x minus 5. So with this information we can put it back into the mapping notation, which will help us determine the transformations that have occurred. So x comma y have been mapped to, and the x has been mapped to x minus 5. And similarly the y has been mapped to 2y minus 4. So on the previous slide we found this mapping notation, and now we're going to interpret that as transformations that have occurred. So the first thing that's occurred is a dilation by a factor of 2 from the x-axis. And the 2 here, that is multiplying the y, is responsible for that in the mapping notation. And in the equation that was given to us, the 2 on the top line was responsible for that dilation. Next we have translations that occur. So we have a translation of 5 units in the negative x direction, and we know that because of the x minus 5 in the mapping notation. And if you have a look at the equation that was given to us, it's the x plus 5 that is responsible for that translation. We also have a translation of 4 units in the negative y direction, and in the mapping notation that comes from the negative 4 here, and similarly it's the negative 4 in this part of the given equation that results in the translation of 4 units in the negative y direction. So they are the transformations that have occurred to y equals 1 divided by x squared.